and I'm back. I was gone for a bit and it felt weird studying and not being live, so I'm back. I have a midterm tomorrow, so that's what I'm going to be working on. Just reviewing and going everything that we've learned in the past 3 weeks. Should be good. I'll be studying mostly correlations, regressions, histograms, bar graphs, using RStudio, which is the software that we're using in class to basically run calculations and create graphs. So let me know what you're studying on and what you're working on, and I'm just gonna get started. If I'm too loud, I'm so sorry. Please let me know. Thanks. Oh, yes, the study guide. That's a lot of questions. Okay. How do I want to go about this? I'm gonna put you on this side. Oh, right. Why is it over with here? Oh my god. Oh, that's really why. There we go. All right. Introduction to stats. Be able to describe and explain at least reasons why it is important to be able to understand and interpret statistics. That's a very good question, Professor. Stats is all around you. Stats can be interpreted. I wonder if this is going to be a short answer question. That feels like a short answer question. That doesn't feel like a multiple choice question. Numbers can be interpreted to match someone's agenda. And if we don't know that, relations, organization, a bunch of other reasons. Let's look at what she said. Oh my god, I'm getting first day flashbacks. I like this one. I use this exact same smiley, sad face, angry face thingy for my review. I wish I could. I'm so excited. I am totally getting distracted. And that's okay. Yeah, this one, but it's ugly. That is so much better. I love it. I am totally getting distracted. So bad. Hehe. Okay. Yay. Hehe. Okay. That's done. Oh my god. That made me so happy. Oh. At least 2 reasons why it is able to interpret. Statistics are everywhere. Statistics are everywhere. That was the obvious answer. I don't know why I didn't go for it. Provide examples of psychological questions that could be answered with statistics. Psych questions that answer with statistics. Okay. Psych questions that can be answered with statistics. Okay. I am so anal about my study guides, my god. Because I like them to be formatted a certain way. Like I like the questions to be bolded. I like to use bullet points. The whole thing. Hi. That's interesting. That's interesting. So like my microphone is picking up not just my voice, but also the music. It wasn't doing that before. That's new. Okay. I'm trying to perfect my stream, y'all. know the three goals of statistics? I have no idea. Okay, none of this is explained to me, the three goals of statistics. I'm so... Ooh, maybe it's in the RMD file. Me too. Script let's look sure. Whoa. Okay. Not that one. It must be the discussion. No, it's not this one. I think it's this one. They moved to Kansas. Hmm. Is it? Okay, this is under descriptive stats. I should look at that first. Huh. Discover relationships between variables? Could that be one? It says goal. I like how these are the first three questions and I don't know the answers. Okay. I mean, I remember all of this. To interpret and what? Discover relationships. Okay, I'm gonna come back to you. Actually, I'm gonna make them all bullet points. I think this is the pistachio one. Alright, inferential statistics, method that uses sample evidence and probability to reach conclusions about unmeasurable populations. Okay, inferential statistics is a method that uses samples rather than populations to figure out the probability of things happening to reach a conclusion that can be generalized to the population. I think that's good. Descriptive statistics, a number that conveys a particular characteristic of a set of data. What? Arithmetic average, call the mean. Oh. Okay, so descriptive statistics for me sounds like more like the method. They summarize a set of data with one number or graph. Statistical technique. Inferential stats use measurements from a sample to reach conclusions about a larger population. Yes. Let's look at the PowerPoint. Oh, I'm gonna wait. What is it here? Generalizing results to the population based on results from the sample. And then descriptive stats describe our data. Describe our data. Methods used to summarize or describe data. So the difference between a sample and a population. A sample is a portion of the population used to create inferences or predictions about the larger population. And then what was it? And then population's population. Also know the different terminology associated with populations and samples. Descriptive stats, inferential stats. What? Oh, parameter versus statistics. The parameter is the population, the statistic is from the sample. American women is I want to say it is a sample. 25 bilingual children's average reading speed. That is a sample. Definitely. So then this one is a population. I think it might be a sample. Infant mortality rate in the US. I believe that is a statistic. Oh yeah, I need to memorize these. So qualitative versus quantitative data. Okay, before that though, I will be right back. I'll be back. Understand the importance of samples for statistics. Huh? Be able to provide examples of potential population parameters and sample statistics that you might calculate. No, I don't want to. Okay. I can do this. Population parameters. Go back to population parameter. Potential population. Whoa, why is my chair so high? Sorry, I probably got shorter. Be able to provide examples of population parameters. The measure you want to know. Okay, I think I can create that. So let's say macarons. We want to know which is the favorite macaron flavor in the different states of the US. Okay. Macaron flavor in each state. And then the sample statistic would be a handful of people from various counties across each state, amounting to maybe 500 people per state. That's still, like, in my opinion, that's a very large statistic, but I feel if you were trying to find the favorite macaron flavor of each state in the US, you'd need like a certain amount of people. Like even just 1% of the population, I feel would be a lot. Because I mean, if you think about it, in Southern California alone, there are about, what is it, 200,000 people? Oh, that's a good question. How many people are? How many people in the United States? We have 328 million. So yeah, I think we have about 200,000 people in SoCal alone.
Oh, California alone has 39 million people. Okay, so I might be wrong. It might be 22 million. Hmm. 39.5 million. It doesn't tell me how many people are in SoCal. But California alone has 39.5 million people. Maybe 500 people is not enough. It'd be like 5,000 people per state. That's a very big number, I feel, for a sample. I don't know. I said a handful of people and now I'm up to 5,000. Sure, okay. It's a what if scenario. Oh my God. Measures. No. Made up of distinct categories. Discrete groups, categories, levels, distinct groups, and then quantitative measures, measurable. So, my TA today actually described qualitative and quantitative measures so well today when she was explaining the difference between a histogram and a bar graph. A bar graph is used when the values that you have aren't aren't continuous, like they don't run into the next measure. They're distinct categories or distinct groups. Like she did a bar graph for gender, female, male, other, gender groups, based on this problem that we were going over. And then for a histogram, it's best used for measures that are continuous or that flow into the next measure. So that's quantitative. It's measurable, has a certain amount. Versus qualitative, which is distinct categories or distinct groups. And then we're going to get into the scales of measurement, which include nominal, ordinal, interval, ratio. That's going to be fun. And then we need to provide examples for the different scales of measurement. So nominal, ordinal, interval, and ratio. Noir. That literally spells out noir, which is black in French. Noir. And OIR. Oh my god. I have an acronym. Okay. Nominal. Distinct categories. Distinct categories, I would say, like different flavors of ice cream, brands, genres, brands, nominal. Ordinal has to do with natural rank, so that falls under qualitative. That could be, for example, like your military status. I think the lines on their sides like mean something, and then the number of stars that they have. So natural order, kind of like a hierarchy in the corporate world. What can I think as natural rank? I would say the quality of a diamond. I'm just thinking, or the carats. I think carats would be ordinal, natural rank. I wonder if that would mean, yeah. I'm talking about carats as in like a 24 carat, 12 carat, I don't know what carat. I'm not that into jewelry, although it is pretty. I don't know anything about it. Diamond quality, the hardness of a diamond, would that be ordinal, natural rank? Sure, I'll put quality of gold or diamonds, jewelry. Can I think of anything else that's ordinal, natural rank? Ooh, how about the big five in the stock market? I feel like those are ordinal. They're always changing, but there's a natural rank to them. Because you're ranking the company, not so much the amount of money that they have. Something like that. Okay. Interval equal intervals. Usually whole numbers. Obviously temperature is 1. Because you have Fahrenheit, Celsius, Kelvin. I wonder what else could fall under interval. She writes height, weight, time, age. You could be 0 years old. In South Korea, you start off as you start out as 1 year old. We started as 0 year old. They go straight to 1, which is interesting. No. I was gonna write it down because then they don't have like a true zero because they start right at 1. But no. Just trying to make my brain work. Intervals, equal intervals. Because time, there could be a 0 start time. So it's definitely a ratio. A true 0. You're always somewhere in time, but you can start something and it be at 0 until you start a timer. And she writes it there. Examples of whole numbers. Money is a ratio. You could have 0 money. What else? I don't know. The speed of a car, that's also a ratio. You could have 0, a true 0. Everything that I'm coming up with is a ratio. Equal intervals. I'm gonna look it up. Examples of intervals. Oh, time of each day in the meaning of a 12-hour clock. That is true. Interesting. Huh. Test scores. You could get a 0. Just get every answer wrong. Interval scales not only show you the order and the direction, the distance between each value on the interval scale are meaningful and equal. You cannot calculate it. No, that's ratios. Okay. You could totally get a score of 0 on the SAT and ACT. Just answer every single problem wrong. Measuring an income of turning a non-interval ordered variable scale into an integral scale. Huh. Yeah, because money is a ratio, but you could turn it into an interval if you create intervals for it. Fascinating. Dates. Years. I trust years. Okay. Voltage. Oh. You could have 0 voltage. I'm confused. Grade levels. Yeah, grade levels. could be 3.5 years old. Be able to define and provide examples of independent, dependent, extraneous variables in a psychological study. Know what levels of the independent variable refers to. Oh, that's the same question that was in our practice problems, and that was actually pretty easy to do once you understand, like, okay, let me go through some that I remember we're doing. 8:24, I'm getting sleepy already. No. Oh, ooh, okay. Small, medium, large. That is nominal. Wait, no. It's distinct categories, but they have a hierarchy. Small, medium, large. That is ordinal. Male, female, other. It's not ordinal, it is nominal. Yes. Lieutenant, captain, major. That is ordinal. 5 seconds, 20 seconds, 100 seconds. I mean, you could say that that's interval, but it's seconds. You could have 0 seconds. So I've said a ratio. 10 years, 40 years, 80 years. I would say that was interval. Because you can't really have, like, I mean, I guess you could have 0 years. I don't know. And then 0 Celsius, 20 Celsius, 40 Celsius. That could also be interval, but, oh no, it is interval because it's temperature. Okay, yeah. Okay, so identifying the independent variable, levels of independent variables, and the dependent variable. So question A is, the results from an experiment indicate that increasing the amount of lighting by 50% as well as by 25% during winter months results in lowered levels of depression when compared to no increase in the amount of lighting. So independent variable is the variable that you are modifying. So what you're changing in order to affect the dependent variable. So for the independent variable, it's increasing the lighting from not increasing the lighting. So the dependent variable is what difference is made if there's no change in amount of lighting, which is the dependent variable. No lighting being changed. The levels that are shown in the example are the increase of 50% and the increase of 25%. That one I actually understand. There's even this harder question that was like, it took me a bit, like my brain was exploding, and conducted a study to see if theater majors are smarter than music majors. She handed out questionnaires in 5 advanced theater classes and 5 advanced music classes. She asked the students to record their GPAs and their majors. So the dependent variable, I put it as a questionnaire. The independent variables levels, I put it as, am I wrong? I put it as a GPA and the major, because that's what's changing. Each student has a different GPA. Each student has, or maybe, the independent variable. the advanced students. Okay, hold up. Wait, this is what I mean by I broke my head. Okay, and conducted a study to see if theater majors are smarter than music majors. Yes, she handed out questionnaires in 5 advanced theater classes and 5 advanced music classes, so there's 10 classes. I think okay, so I made the dependent variable questionnaire because a questionnaire is doesn't change from student to student. The questionnaire is like the base. Everyone's answering the same questionnaire, so that is the one that is being tested against the questionnaire. So that is the dependent variable, and then the independent variable is the varying in the students, so the advanced students, so the all the advanced students in all of those 10 courses, which could be like, I don't know, like 100 students or something. And then the levels in the independent variables has to do with their GPA and their major. I actually think it's their GPA. Their GPA and their major. So I put their major because just because they're in an advanced theater class or an advanced music class doesn't necessarily mean that that is their major. That doesn't mean that, oh wait. Okay, now maybe it is. So the IB level, I'm seeing. Okay, so maybe the IB levels is the GPA, the theater students, and then the music students. Because those are 2 different levels of students, and then the GPA. So maybe the independent variable is the GPA. And then the levels are the theater student GPAs or the advanced music major GPAs. I think that's it. So I think I got that one wrong. Okay, I'm gonna write it in parentheses. GPA is the IV, and then I'm gonna put it might be those 2. The questionnaire, though, is definitely the dependent variable. Okay. I should be fine with this question. Problem set 2. Be able to turn a data set into a frequency distribution, grouped frequency distribution, frequency polygon, and histogram. That I know how to do. Be able to interpret frequencies, group frequencies, frequency polygons, and histograms, and whether they are created correctly. That I should also be able to do. Know when it is appropriate to use a histogram over a bar chart. That is in my notes. And I actually kind of already explained that during the stream. Okay, know the names of the different shapes of distributions and how to identify them visually. So this has to do with positive skew, negative skew, and then normal distribution. So if it's a positive skew, then the graph will be leaning toward the right, and if it's a negative skew, the graph will be leaning toward the left. So then the numbers are going down. That I should be able to do. Know the measures of central tendency discussed in class and how to calculate them from both a raw data set and a frequency distribution. That I don't know. Oh yeah, I haven't even done problem set 3. I'll probably work on that tonight too, because that's correlation and regression. I just started to understand regressions today, and then I haven't gone over correlation at all. So we'll see how I do. Okay, I do need to go over measures of central tendency. Okay, measures of central tendency are mean, median, mode. Oh, then I do know those. I just didn't know what that meant. Okay. Mean, median, mode. Okay. Alright, give me one sec. I will be right back. No measures of central tendency, mean, meter, mode. Mean is adding up all the numbers and then dividing by the total number of values. Which gives you the average. And then you have the median, which is just ordering all the numbers in order, and then finding the number in the middle. And then you have mode, which is just the number that occurs the most. And then how to calculate them both from a raw data set and a frequency distribution. So for that one, I'm assuming she just wants us to know the, what's it called? What is that called? What is that called? It's the program for it, I don't know, but that. Okay. It's just mean, and then parentheses, whatever you want to find the mean of. So this is the frequency table. I'm going to leave the Earl Grey for last. so used to motion now. Okay. So this was if the mean is less than the median and the mode, then it is negatively skewed. But if the mean is more than the median and the mode, then it is positively skewed. And that is in that one graph. Where'd it go? Wait, what? I think everything is wrong. Oh, here it is. If the mean is less than. Wait. Wait. That must be wrong. That must be wrong. This is a positive skew. This is a negative skew. What? Oh my god, I've been wrong this whole time. It's the opposite of what I think. What? But I've given the answer for these skews and I've been right. I'm so confused. Oh my god. What the fuck? Okay, I'm so sorry. No one has ever told me anything different. So both of these, this is a negative, this is a positive skew. I've been wrong this whole time. I'm still blown away. Everything I know is wrong. I'm dead. Okay. So, if it is a negative distribution, the graph will be leaning this way. If it is a positive distribution, it'll be leaning this way, which is just, I don't understand. I have to live with it. I'm kind of disappointed. Not in myself, just disappointed. Understand the definition of variability. What does variability tell you about your data that measures the central tendency? Do not. Variability tells us variability tells us the change in relation to the mean. So variability includes range, standard deviation, and variance. Variance being standard deviation squared. Variance allows us to translate the standard deviation into statistics, such as percentages, which help us to communicate data better to the general population. OMG! And then range doesn't really tell us much. It just kind of tells us not the parameter, but the levels needed for the data set to give us the standard deviation and variance. It tells us the change in relation to the mean. What it doesn't tell us about our measures of central tendency. Our measures of central tendency tells us where the data lies on the graph, but it doesn't tell us how the data, the distance of the data away from the mean, like where certain data is, the deviations, the whatever. I know what I'm talking about. I'm going to be very sad if I have to explain that tomorrow. Know how to calculate the range and interquartile range of the data set. So the range, you take the smallest number and you take the highest number, and then you subtract them from each other, and that gives you the range from a number to the other. And a quartile range is the bottom 25% and the top 75%, and you subtract them from each other to find the first interquartile range, the second, which is the middle, and the third interquartile range. 1, 2, and the middle. 1, 2, 3. I guess you could say 4, but yeah, okay. Understand what the standard deviation tells you about variability beyond the range. Standard deviation tells us what the distance is in relation to the mean, where a value stands in relation to the mean. Know the terminology for standard deviation associated with populations for a sample versus inferring from samples. That I do not know. I'm assuming it's these. Sample variability S, population variability sigma, S hat. I thought it was Y hat. Standard deviation, average deviation around the mean, dispersion around the mean, average deviation from the mean. Sure. So then we have sample variability. And then we have estimated. Okay, I think that's it. Inferring from samples, estimated population variability. Hat denotes variability, denotes estimation. Now, one of two ways of computing the standard deviation. The code. SD, parentheses, data, money, the variable, I think. Let me see. Where is, that's a correlation. SD, and then your variable. Oh crap. That is definitely this. Oh, I don't know. Know how to calculate standard deviation, solving for this sample, SD, population SD. She doesn't really go into the question about I remember very little of us going over S mu and S hat. We didn't spend a lot of time on that, like, at all. Yeah, I'll probably start working on problem set 3, because I feel like once I get through problem set 3, I can answer C and D and E. Okay, so these are some practice calculations. Provide an example of a research question in psychology that can be answered with statistics. What is possible population of interest for this question? Describe the data that you might collect to answer this question. What would you measure? Which scale of measurement would you use? I'd probably do something based on sleep, just because I've done a lot of work in relation to sleep. 2, you conduct a research study looking at how many dogs people own. You end up with the following data: 4, 6, 3, 1, 1, 1, 2, 3, 4, 9. Organize the data into a simple frequency distribution, which would be that one graph with the numbers on top and the numbers on the bottom. How in the world does one person own 6 dogs? I mean, I've only seen that in Hannibal. Willa owns like 5 or something. Okay. Describe the shape of this distribution using the terms you learned in class. Okay. Calculate all 3 measures of central tendency from your data. Calculate the standard deviation from the data provided. That I can do all of that. Your friend is interested in understanding the relationship between number of cats owned and happiness in life. They collect data and analyze the correlation and find a Pearson's R value of -0.01. Interpret this value for your friend. The correlation between the two, it has a negative and weak correlation. Meaning that cats own isn't directly correlated to the level of happiness in life, and there is a very weak relationship between the two, because the R value of -0.01 is very close to 0, and it is negative. That's what I would say. Ryan thinks that eating more spicy food will make you sleep worse. He collects the following data to investigate this claim. Number of spicy tacos eaten per week. Average hours of sleep per night. Based on this data, how many average hours of sleep per night would be expected for someone who eats 20 spicy tacos per week? That I don't know how to do, and I think that has to do with correlations and regressions. According to the Department of Sleep Research, the average number of times someone snoozed their alarm before waking up in the morning, 5. With a standard deviation of 0.53, what portion of people snooze their alarm more than 6 times? Wow, that almost broke my brain. Okay, so these last 2 I don't know how to do, and that makes perfect sense because I haven't even done problem set 3. So let's work on problem set 3. Okay. Has anyone said hi? No, not yet. That's okay. Do, 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 do. There's like so much information here. Oh my god. This is so. Okay. Let's see. What's this? Oh my god. Okay. No. Mm, there's a Coursera. So I could potentially get a certificate in this. And I would get a certificate. Oh my god. Oh. Oh, this one. No, I saw this before. I don't think I'll ever. Oh. Oh no. What did I do? Okay. That's enough of a distraction. In your own words, what is a correlation? That is a very good question. I don't know. Yeah, getting distracted a lot. Below are data on extroversion and agreeableness collected from 6 different countries. Country A, B, C, D, E, F. Extroversion 2, 8, 14, 6, 12, 6. Agreeableness 30, 40, 46, 36, 48, 40. All right. Create a scatter plot of the data above. All right. A scatter plot. I don't even think I know how to do that. ggplot, scatter plot, ggplot, data, s, and then the variable x. So e, and then a, plus and genome underscore point. All right. Library.gg. No. I forget what the thing is for. This one. Oh, country data. Okay. C-bind, got it. And then Um, oh, I need that. I think I need this before I can do that. So, LM are hours studied. Exam grade. Country. Country. Okay. Do I need to name LM that? Is that why? I think I do. Because it won't give me... Okay, maybe it'll give me the scatter plot without it. And it didn't. What? Oh my god. Okay, now I'm stressing out. I am stressing out. What? I'm stressing out because the tables aren't coming out. And I really don't like that. I think I should take a break. Because... Okay, so, none of the stuff wants to come out the way it's supposed to come out in our studio, and that's, like, making me freak out. But I just noticed that I've been live for 2 hours, and I haven't taken a break yet, so, I'm gonna do that. I'm gonna take, like, 15 minutes, take a breather, and then I will be back. I'm feeling better. Okay. So I think what I'm gonna do is I'm gonna create a file. Our notebook, our text file. Sure. Create a new text file. File. Save. We're gonna do what is this called? Code cheat sheet. Interesting. Okay. Actually, no, I'm gonna do. Can I create a new window? Can I get 2 RStudio windows? Well, let me do that. I don't think it'll let me do that. It does. Perfect. Okay. We're gonna do week 2 and put over here, and intro. Do I need intro? No, I don't need intro. Problem set 2. And put it over here as well. Descriptive stats section over here. Okay. Oh, this is pure text. Okay. I think I actually need like a this. Let me. It won't. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 120, So this is descriptive stats. Problem set 2. That's a whole bunch of other things. Fascinating. I didn't know that was a thing. So, okay. Now we're going to go into correlations, scatter plot. this one went through. This one is perfect. Okay. So this is the one that's on regressions. So this one ran the graph. The one that I'm trying to do up there just won't do the graph. So see, like, it shows this here, but then when I go over here to problem set 3 to run it, it says error. So I'm not sure what I'm doing wrong, but I'm gonna fill this out and then I'm gonna go back and then I'll be able to figure it out. So I'm checking the group chat for this class, and there's one student that was just like, okay, from 1 to 10, how hard are all of you studying? I would give myself maybe like a 6 to 7. I wouldn't give myself like a 10. Because I have a pretty good basic, like, knowledge base of statistics and a lot of the stuff that we've been going over. So I feel pretty confident in being able to like answer the question and be able to like give examples. But I'm just trying to make RStudio work, because I feel like if I can understand how to input it in RStudio, then I'll definitely be able to answer the questions a lot easier. But yeah, I give myself like maybe like a 5 to 7 around there. Okay. Sets regression, scatter plots, and correlation. Oh. And then she gave regression supplemental. Excuse me. I think it was just more examples. Yeah, see, this comes out perfectly, but for some reason in mine it doesn't want to come out. So descriptive stats, frequency table, I think this is B, and then C is correlations. Oh, so I guess. I haven't gone over Z-scores, but Courtney, our TA, went over it pretty well, so I feel okay about it. It's not just seeing it. Oh, the answer's right here. I have the answers. Okay. Okay. So I have everything open that we've used so far, and this is it. So now I'm gonna put this one right here and do problem set 3. Discussion 4. This regression. Alright. Put this up here. And then those are just my notes. I don't know, my computer keeps doing that. Okay. So these were given. Coordinations. So students, studied hours, exam, EA, and then he bound the data, C-line data frame, student, E and A, country data. Right, now we're making the scatter plot. So let me get rid of this. Install a package, which isn't here, but it's up here, right? And then we're gonna do library ggplot2, and then ggplot, the name. Let me clear these. Yes. Let me run this one more time. So then I just have this, and then I don't need to write that. ggplot country data, aesthetic, and then hours TV. Where am I? I'm down here. Aesthetic, hours studied, exam grade. That is E and A. Maybe that's what it was. And then geom underscore points. And there we go. And it ran! Yay! Okay. So that's a scatter plot. Right, and then if you want the what is this called again? LM? What was that called? LM has a name. What is that name? linear model. Let me write that down here. This is to get line it best fit. Jump point plus smooth method equals ln, and then that gives us that. Perfect. And for some reason we wrote ln here. It's scatter plot. I don't think we had to, but I did. I'm not sure why. I don't really want to run it because I don't want to confuse what I already have here. I don't think I had to do this. So I was able to find the scatter plot without it. Okay. Calculate the correlation. What does this value mean? And then that's going to be this one, core. And then it's going to be the data set, country data, money sign, and then E, A, oh, and then country size, data, money sign, A. And that gives us the correlation. I mean the correlation, I forget what the correlation means. Correlation is basically correlation. Okay, regression, correlation. Correlation shows, oh, the strength and weakness. Right. So that's the correlation. And 0.94 just shows that it is a positive correlation. It is both a strong and a positive correlation. Right? Pretty sure I'm right. Let me see. So we did this. This is def positive. Now we need to find the correlation. Right, this is the scatter plot. And then there's a strong positive correlation. Yeah. So I was right. This is, and I'm gonna write it in, I don't want to write it in blue. I found a different color. Okay. This is a, oh. What's it called? Amiability. The coefficient of determination. So this will be core, and then it's just this but squared. Control copy, Control V, and then square. Which will be $39.9. Terms determination. This I've been live for 3 hours. Oh, hi, thank you for the follow. Jordan. Oh. I feel so bad because I didn't see it when it happened. But thank you for the follow. Ooh, I'll put it in the in the chat. Dang it. I don't remember. She explains it here. Okay. Coefficient of determination is just the standard deviation squared. Correlation is descriptive, regression is inferential. Tell us what is happening. So this confirms how the dependent variable is influenced by the independent variable rather than an extraneous variable. So here the dependent variable in our question is dependent variable. So dependent variable. I'm assuming the dependent variable is extroversion, agreeableness. Extroversion being extroverted, being likes to talk to people, agreeableness. So I think the dependent variable would be agreeableness, and then extroversion. That then you can do either or. Yeah, this one is more, instead of a would it be good for this would be maybe a bar graph, a country. Is that the? That's not the dependent variable. The exam score. Change in study hours. Okay, so I would say change in extroversion, change in agreeableness. So how much of a change in the extroversion is because of a change in the study hours? That doesn't make sense. Another, how much of the variance in scores is shared between the two categories? Okay, how much of the variance is shared between the two categories? R squared is proportion, so it can easily be changed to percentage. So about 60% of the variance is due to this really tells us how much variance is due to a change in extroversion and a change in agreeableness. I hope I'm right. Okay, let's look at this slide for correlation. Oh, okay. So I was so confused earlier. Okay. So the direction of the line is different for correlations than it is for descriptive statistics. Got it. Okay. So earlier I was panicking because the direction of the line was different for descriptive stats for a negative and positive skewed relationship than to correlations. Okay. Oh my god. Okay. So I'm not wrong. I was just thinking of the wrong thing. Okay. Oh, okay. Effect size small, medium, large. Effect size small, medium, large size. Coefficient of determination. This one. The shared variance. I'm not sure I'm saying it correctly. Okay. Let me put this into else. Okay. Does extroversion cause agreeableness? No. It means there is a strong connection between them. Okay, good. Okay, you gave UCR students a survey asking about their general happiness and selfish behaviors. You find the correlation is negative 0.64. Interpret this value in the context of your study. The correlation describes a negative and strong correlate. Correlated. That's interesting because a negative times a negative equals a positive, and yet it keeps it as. Maybe I'm gonna do this. Nope. There it is. There it is. Okay. Or less than 50%. Excuse. I'm almost done with problem set 3. Yay. Um, I'm messaging an old friend, and they're Filipino, and they cook like the most delicious food like ever, honestly. My favorite Filipino meal is shrimp sinigang. It's so delicious. I highly recommend you to try. Um, that is so random, but it's really good, I promise. Okay. I am almost done. I am almost done. I am almost done. I am almost done. 10:48. I think I should finish this by 11:15. After I finish this, I'm gonna go ahead and end the stream because I'm gonna have to wake up. I don't have to wake up early tomorrow, but I'm gonna do a morning study stream as I study for this exam. So yeah, you'll see me again tomorrow. They found two variables were correlated. Interpret this bar value. R value is the correlation. Create a scatter plot of the data. All right. I already have those, so now I just need, where's my first scatter plot? This one. I wonder if I need to. C-bind. There was a C-bind. Do I need... I think I do, because I need the... So maybe... I wonder if I need it. Let's see, let's try it. ggplot. IQ cat. And then the first variable is number of cats. And wait, IQ. Huh, it did. Okay. So I don't need 3. Interesting. Can we say anything about whether a high IQ causes an increase in cats? That is so funny. Yeah, this question is it's so out there. I should probably say this. Oh, my eye. Can we say anything about whether a high IQ can causes an increase in cats in a child's home or vice versa? I think if this were true, if they did a wide enough survey of this and it got the same correlation coefficient, a lot more people would be owning cats. Cats would be revered. That's hilarious. I mean, they were at one point in Egypt, right? Deliverers of the soul or something. Can we say anything about whether a high IQ causes an increase in cats in a child's home or vice versa? Can we say anything about this? Okay, I can say this. Since the relationship, oh my god, my eye. Since the relationship between, no, not the relationship. Since the variance between the two variables, high IQ and number of cats in the home is both positive and strong, we can determine that if the number of, we can predict that if the number of cats decreases, the IQ of the child will also decrease. But we cannot determine whether or not the high IQ causes an increase in the number of cats in a child's home. We can predict that if the child decreases, the number of cats in the home will also decrease, but we cannot determine whether or not the high IQ causes an increase in the number of cats in the child's home. That is hilarious. And vice versa. That I remember from discussion. She was talking about how damn, where is it? It is a strong positive correlation. If it's strong, positive means that one scores up and the other value goes up as well. Positive correlation, yes, okay, good. Since the variance between the two variables, high IQ and number of cats in the home, is both positive and strong, we can predict that if the IQ of the child decreases, the number of cats in the home will also decrease. But we cannot determine whether or not the high IQ causes an increase in the number of cats in the child's home and vice versa. So. What? Come on, work with me here. Okay, 6 just wants to be able to predict how many cats children of certain IQs might have. What type of analysis should they use? What was it? Correlation describes the data, right? Regression. What was it? Can help predict. Yeah, they haven't asked us anything about making a regression line. I think that's what this was for. Just wants to be able to predict how many cats children of certain IQs might have. What type of analysis should we use? We should probably use a regression analysis. Regression, because regression allows us to make predictions. Oh, but then I put that in my head. Okay, maybe let me go back up to let me go to, what do I have here? Regression, correlation. Let me go back to correlation. And nothing. Okay. Let me go to regression. My eye hurts. Okay, let me go to the PowerPoint. Correlation does not mean that there is causation. Yes, we know that. Let's look at regression. Gives us our predicted y's, gives us error. Oh my goodness. Create a regression. We should use a regression analysis of the data because the regression line offers predicted values, which is what Jess would like to predict the how many cats children of certain IQs might have. Okay. Create a regression equation, including the intercept and the slope. Like, I didn't see that coming. Right. Let me go back to my cheat sheet. Regressions. Right. We need... But we don't have any data. Create a regression equation. So we have ln y x data set. That is that gives us the intercept, the slope, the data set. We use the function y hat in our So I didn't need this. The child has an IQ of 115. How many cats would we predict in his or her house? But you didn't give us any data. Are we supposed to be using this same data? I think we are. Okay. So then, that is yx, and then the data set. Okay, so we have LM, and then we have IQ. Adding somebody sign. There's the squiggle, and then number of cats. Yes, comma the data set, which is IQ cat. Whew. All right. So that gives us and then we're going to try to find the predicted values. So regression. Okay, so that's that. And then let's keep going here. Regression. We're going to name the regression this. Control copy. We're going to name it that. Okay. And then regression money fitted values. No. Oh, my bad. I didn't remember this. And then those are the fitted values. So, if a child has an IQ of 115, how many cats would we predict in his or her house? Oh, right. Okay. There we go. Okay. So we have what is this? The intercept 80. Okay, let me look at this again. Okay, so 0.78. So y equals mx plus b, just to help me. So 1 times, no, this would be y hat. This wouldn't be y equals mx plus b. This would be y hat equals, no, this would be the y hat, not y. Where is the this one? Copy. Let's see what happens. Ooh. Right. So A is the intercept, which is 80.811 plus, then we have 1 for some reason. 1 times 1 times 6.081, which doesn't make any sense, but that is what we have. So it's 86 point. That doesn't look good. Oh no, that is actually accurate. No, it is not. 1.4 for 1 for 1. This number of cats is off. I think I did the formula wrong. I did. No, I didn't. IQ, number of cats, IQ cat, data frame. standard values. All of that is correct. IQ cat. IQ, no cats. Okay, so for 2 it worked. For 1 it didn't. I'm so confused. Oh, I think this confused the information. Because that says number of cats, and I'm just like, that's not correct. Okay, let me clear this. Yes. And run all. Yes. It's literally right there. What the heck? Why is this wrong? When I write 2, it's accurate. Let's see when I write 3. When I write 3 is 99. So that would be error, right? Let me put 5. And then 6. I have no idea. Okay. File. Save as. I think I should be fine. Okay. Alright, so apparently I've streamed for 4 hours and that's insane. Thank you for sticking with me. It is already late. My eye is in pain. And I need to get some sleep because I have my exam tomorrow, which I've said at least 5-6 times today. Anyway, like, subscribe, follow. I don't have a donation button yet, and I don't know how to do that, but it's okay. Study with me next time, and good night. Bye.